Limiting error. Most of manufacturers are giving a scale for accuracy, means the device is accurate within certain percent. Like for example, voltmeter is accurate within plus minus 2%. That means there will be an error of 2% in your reading. But keep in your mind here that the 2% will be if you are reading at full scale. What does it mean? If I am measuring 100 volt with the meter having a scale of 0 to 100 volt, then the error will be plus minus 2%. Now, what about if I am using the same meter, which having a scale from 0 to 100, but to measure 20 volt? If I want to measure 20 volt, what will be the error? The error is going to get bigger. As we are getting farther from the full scale toward 0, of course, the error will increase. So how to minimize this kind of error? It's by using the scale or measuring the value which is close to the scale, to the full scale. Measuring the value which close to the full scale means if I am having or the expecting value is to be 50 degrees Celsius, for example. If I'm having the three instruments, 1, 2, and 3 instruments, this one from 0 to 20, the scale. This one from 0 to 60 for this one. And this one 0 to 100. Which one is the most suitable? The most suitable will be 0 to 60 scale. 0 to 60 scale is the suitable one to measure the 50 degrees Celsius. If you are using 0 to 20, it's error because you are using the scale out of, you are using a wrong scale. But 0 to 100, with 0 to 100, we can measure, it's no problem, but the error will be bigger. The smallest error will be when you are using the scale which is closer to the value to be measured. So 0 to 60. Example to understand the limiting error. Let us look at this example. Pressure gauge with measurement range from 0 to 10 bar. So the range of measurement is 0 to 10 bar. Has quoted inaccuracy of 1%. FS means full scale. That means 1% of the full scale reading. Okay. Now again, to understand what he means, this is the reading, this is the scale. The scale starts from 0 to 10 bar. Okay, so now the error will be plus minus 1%. What is the maximum measurement error expected for the instrument? So the maximum measurement error expected will be calculated as you see here. The maximum error is equal to 1% into the full scale. That means 1 bar, 0.1 bar. 0.1 bar. The maximum will be 0.1 bar, 1% of the full scale. Keep this in your mind. Now let us look at the second one in part B. In part B, he's saying what is the likely measurement error expressed as percentage of the output reading if the pressure gauge measuring a pressure of 1 bar. That means we want to measure 1 bar here. If the pointer comes to measure 1 bar, what will be the error? Is it remaining as it is before? Is it 1% as it was? Let us check. He's saying here, when measuring 1 bar, the maximum possible error of 0.1%. The error will be the same, whether you are measuring 1 bar or 10 bar or 5 bar, the error will be the same. So when you compare this error with the value, the measured value is going to be 0.1 over 10. Remember, we are measuring 1. This is 1. So 0.1, which is the maximum error, as a percentage of the measured value, which one? It's into 100% is giving me 10%. So if I want to look at this one carefully, I will find that when I measure 10 bar, I am getting a percentage of error of 1%. When I am measuring 10 bar, the percentage of error will be 1%. Okay, how about if I measure 1 bar. If I measure 1 bar, the percentage of error will be 10%. So this is telling us that if you are measuring with the scale far from, measure the value which far from the scale, you are going to get the error bigger. So always keep in your mind to select the scale which is close to the value to be measured, but the value to be measured must be smaller than the scale. This is for sure. The value to be measured is smaller than the full scale, but close to it. Another example on limiting error. Digital thermometer reads from 120 minus up to 300 degrees Celsius. The accuracy is granted to plus minus 2%. That means the error or the range of error will be plus minus 2% of the full scale. Determine the possible temperature range when indicates 80 degrees Celsius. So we are measuring 80 degrees Celsius. What is the possible value of the measured quantity? So first of all, we want to know what is this 2% means. The 2% here means what? It's 2% of the full scale. What is the full scale? So we will calculate the range here, the range or the scale. The range is 300 minus 120, which equal to 420 degrees Celsius. So the whole range is 420 degrees Celsius. It's something like the meter is 0 to 420 degrees Celsius. So when we calculate the 2%, it's to be calculated out of this value, out of 420 degrees Celsius. So when we calculate it here, you calculate it, we will find that the value is 8.4 degrees Celsius. So 2% of 420 is equal to 8.4 degrees Celsius. Now, the measured value, which 80 degrees Celsius, the measured value, which 80 degrees Celsius, is actually 80 degrees Celsius plus minus 8.4, which means the value could be 88.4 degrees Celsius. That means 80 plus 8.4, or it could be 80 minus 8.4, which equal to 71.6 degrees Celsius. So the 80 degrees Celsius, in reality, it's a value between a range of 88.4 to 71.6. Another example on error calculation. The example is saying here a voltmeter having a sensitivity of 1 kilo ohm per volt is connected across a resistor in series with milliammeter, reading 80 volt at 150 volt scale. The meaning of that, we are having here a resistor, and the resistor is, the voltage of the resistor measured by voltmeter. The voltmeter have range of 0 to 150 volt, and it measures, the value measures is 80 volt. Means the voltage across the resistor is 80 volt. The voltage across the resistor is 80 volt, and the range of the meter is 0 to 150 volt. When milliammeter reads 10 milliampere, so that means the resistor is connected with a milliammeter, and the milliammeter measures 10 milliampere. Calculate the following. First of all, you want to know the apparent resistance. The apparent resistance usually is what is to be calculated from the measured voltage and the measured current. Then the actual resistance. When he say the apparent, of course, we are looking for the value of this R. This R. So the value of this R, we know that R is equal to V over I. So the measured V divided by the measured I will give me the value of the resistor. But this value is apparent value, not the actual value. It's apparent value. Then after that, he's asking us to calculate the actual resistance, then the error. Let us see how he did it. Okay, before we start the solution, let us keep something in our mind. We have a resistor which we need to measure its value, and we connect across it a voltmeter. The voltmeter by itself is having internal resistance with the measuring element. So this is the voltmeter. Okay, let me just put it in this circuit. This is the voltmeter. Now, when I want to measure the apparent value is what is calculated by the voltmeter and the ammeter. It will give me the apparent value, but it will give me the resistance between this point to this point, which actually the resistance of the resistor we are measuring, which Rx, paralleled with Rv, the voltmeter resistance. So in the apparent value, we are getting Rx paralleled with Rv. So what are we going to do after this? We are going to calculate Rx by itself, and we will see what's the difference, or sorry, what is the error in measurement due to the presence of Rv. So let us go through the answer. In the answer, he said R total is equal to V over I, which equal to 8 kilo ohm. That's very clear. Now Rv, the resistance of the voltmeter, the internal resistance of the voltmeter, is to be calculated as sensitivity into the scale, into the range. So S into into V range, which equal to 150 kilo ohm. Now we are having two resistors in parallel. Their total is 8 kilo ohm. From them, we need to, and Rv is known, we need to calculate Rx. You can do it by any way you like, but I put it here in a form of formula. So Rx equal to Rv into R total over Rv minus R total. Substitute, you will get Rx equal to 8.45. So the value of this resistance by itself, the resistance we are measuring, is 8.45. Now we measure at the beginning 8 kilo ohm, and now it's 8.45, the actual value. From there we can calculate the percentage of error by using this formula. We will find that the percentage of error equal to 5.3%. Another example, similar to the previous example, a millimeter reads 600 milliampere and voltmeter reads 30 volt on 150 volt scale. If the voltmeter sensitivity is 1 kilo ohm per volt, calculate the following: apparent resistance, then actual resistance, and error due to loading, due to Rv, if you remember in the previous question. So this question is very similar to the previous question, but with different values. Notice that he calculate R total, then he calculate Rv, exactly same style. After that, we calculate Rx, then the error. So the question is the same, but different value. Another example, a voltmeter reads 70 volt on 100 volt range, and milliammeter reading 80 milliampere on 100 milliampere range. Used to determine the power dissipated in resistance. Both these instruments are guaranteed to be accurate within plus minus 1.5%. At the full scale deflection, determine the limiting error in the power. To understand what he mean here, we are having voltmeter having a range from 0 to 100, and it measures 70. Another device, milliammeter, this is voltmeter, this is milliammeter. Its range is 0 to 150 milli, and it measures 80. Both of them are guaranteed to within plus minus 1.5%. We need to get the value of voltage and the value of current to calculate the power. So we need to know what is the limiting error in the power, in the result of measurement. So to do this kind of questions, we are going to calculate the value or the percentage, the value of error. I mean the plus minus 1.5% plus minus 1.5%. How it's going to affect the voltage? It's by 1.5 volt. That means if we measure 100 volt, we are expecting the error of 1.5 volt. How about if we are measuring 70? If we are measuring 70, you are going to calculate it as a 1.5 over 70 into 100. So the percentage of error will be 2.145. So the percentage of error in the voltage will be 2.1. Why it's not 1.5? Because it's 1.5 when we are measuring 100. But when we are measuring 70, it's 2.143%. Same thing in the current. We are going to do the same thing in the current. We will find that the percentage of error in the current is 2.813%. So what is the total error? The total error, if we have the percentage of error in the voltage and the percentage of error in the current, the percentage of error in the power will be the total. Because remember that P equal IV plus minus something percent. The voltage into, I mean, here he didn't ask me for the power, but if you want the power, it's just the current into the voltage. You want to know this value. This value is not known for me. What I have the error of current, the percentage of error of current, and the percentage of error of voltage. What is the percentage of error for the total? He said it's the total percentages. So it's the percent of error of the voltage plus the percent of error in the current, which result in 4.956%. He wanted to tell us here that when we are having two instruments, each of them having error, the error will affect the result of calculation, which we are using the values of those instruments. Another example, 600 volt voltmeter is specified to be accurate within plus minus 2%, the limiting error, you remember this, at full scale. Calculate the percentage of limiting error when the instrument is used to measure a voltage of 250 volts. Very simple question. This question is very simple. So if we are measuring 600, the voltage or the error in voltage will be 12 volt. How about if we are measuring 250 volt? If we are measuring 250 volt, you will find 12 over 200 over 250 over 100% equal to 4.8%. As I mentioned earlier, when we talk about limiting error, here you want to teach us something. Don't go far from the full scale of the meter when you are using it. What do I mean by this? If the meter here is 0 to 600, that means use it when you want to measure a value close to 600, close and lower than 600. Close and lower than 600. Don't use it to measure a values close to 0, because as you are getting closer to 0, the percentage of error will getting higher and higher. Okay, in the next week, we are going to study more topics related to error and error calculation. Thank you. I wish you all the best.